thank you everybody for coming out to my talk, Active Directory. My name is Ryan Houseknecht, and we'll get into introductions and stuff in just a moment. I'd like to start everybody off with just a really brief story. So prior to my current role, I did vulnerability management and penetration testing. And one of my customers that I did vulnerability management for well over a year called me one day and said, hey, Ryan, we're ready to do a penetration test. I said, okay, well, we tried to get you guys to do this last year, but what's changed? And they were also a vulnerability management customer, so I know that I worked with them over the past year or so doing vulnerability management. They were in a really good spot in their vulnerability scans. So they said, we're ready for a pen test because our vulnerability scan shows no criticals. Okay. Well, their network got owned in like 20 minutes just because I compromised things via Active Directory. Really brief about me. My name is Ryan Houseknecht. That's how you pronounce my last name. I'm a security consultant at SpectreOps, where we primarily focus on adversary simulation, red teaming. So that's primarily what I do is red teaming. Occasionally I'll do some threat hunting stuff and purple team, but I'm also the instructor at UNC Charlotte for cybersecurity. For the past 5 years now, I've been the instructor and organizer at the FBI InfraGard Cyber Camp in Charlotte. I was an instructor at Black Hat this year for our Red Team Operations course. I have a couple certifications if that matters to you, and then you can follow me on Twitter at Housek with a 3. This is a real picture of me, not photoshopped at all. Popping my first root shell, circa 1995. So what is this whole thing about? Well, the whole purpose is Red Team's existence is to help Blue Team. And what I realized over the course of doing penetration testing and now red teaming for a couple of years, that there is a massive difference in maturity between small and medium businesses and enterprises. And when I would look at a company's vulnerability management and vulnerability scans, and even if they were pretty clean, vulnerability scans miss a lot of the big details in Active Directory. And Active Directory is like super common. 95% of the engagements that we're on are in some way dealing with Active Directory. So with vulnerability scans missing all these exploits in AD, you can't just rely on your vulnerability scan to say, I am secure. Also in this presentation is super high quality Microsoft Paint edits. I am too cheap for Photoshop, so you get amazing quality Photoshop or Microsoft Paint edits. So little disclosure first, I am not dropping any 0 days here. These attacks have been well documented. They are not new, but with that being said, they are still applicable today. I basically took the most common attacks that I still use against enterprises, against small, medium businesses, and I kind of put them all together in this presentation. So the takeaway from this is to recognize what these are, because these can all be fixed via group policy or within Active Directory. So at no point am I ever going to pitch a sales product or anything like that. Everything that I do here is with open source tools, 100% free, or you can get them off GitHub. So brief history of Active Directory. It's a directory services for Windows. I introduced in Server 2000. And it's used to manage the domain. So if you've ever had a Windows laptop given to you by an employer, most likely that is connected to Active Directory. It utilizes things called objects, and the best way to know what an object is in Active Directory is everything is an object, from the domain itself to users, computers, policies. So whenever I say object, it can be any one of those things. And the way it administrates things is through these objects called group policies. Group policies are things that control your password length. They control password complexity. They control what you can and can't access. It controls a lot of things. And we're going to get into that more in detail. You can group objects into things called organizational units, OUs. OUs, think of it this way. If you're in an enterprise and you have your finance department, you want your finance users to be in the finance organizational unit, where you want HR users to be in the HR organizational unit. It's a way of organizing people and you can apply policies to these organizational units. So you don't want, finance being able to access HR's data and vice versa. So default group policy favors convenience over security. So whenever you install Windows Server and you install Active Directory and get everything going, the default group policy is not secure by any means. And as we all know, security is the complete opposite of convenience. If your password is super hard and long to remember, it's going to be a lot more secure, but it's also a lot less convenient. Frankly, group policy, the default group policy that comes in Windows is crap. It's full of holes that I'm going to get into and all these attacks. So if you're still using default group policy in your domain, hopefully this is a little bit of an eye opener. So going back to my original story, on this penetration test, I knew, again, I did vulnerability management for this customer for a while, so I knew I wasn't going to be able to exploit any missing Microsoft patches or anything like that. So I was on site. I found a little side room with an IP phone, went in there, closed the door, unplugged the IP phone, and plugged it into my computer, and I was on the network. Vulnerability 1, anybody can get on their network by just plugging in. The next attack that I did was I had to gather credentials, because I was on their network, but I wasn't an authenticated user. I just had access to some of the IPs and devices on that network. So I had to get credentials. And the first attack that I looked at, and I usually, first thing I try, is something called LLMNR and MB TNS spoofing. Has anybody here heard of LLMNR before? OK, a couple people, good. LLMNR stands for Local Link Multicast Name Resolution. It's a mouthful. NetBIOS, or MB TNS, stands for NetBIOS Naming Service. It is a protocol in an API, with NetBIOS being the API. These are quote-unquote backups to DNS. Not alternatives, but backups. So if DNS were to fail, it could resolve names via NetBIOS or LLMNR. It is natively an insecure protocol because it trusts any response as authentic. And I'm going to show you what that looks like. For example, if you have a workstation and you go to Windows Explorer and you type in file shray01, where you're trying to really get to file shray01, but you made a typo. So it goes to the DNS server and asks, do you know where file shray01 is? DNS server says no. So what it does next is it shouts to the entire domain via broadcast with the LLMNR protocol saying, does anybody know where file shray01 is? And what an attacker would do is they would listen for this, and they would accept this, accept the request and respond with, yes, I know where this is. However, in order for me to tell you this, you have to encode this challenge with your password hash. And then they get the password hash back, and they can decrypt it that way. So a common question is, OK, how many times are people actually mistyping file share names in Windows Explorer? And the answer is not often. However, what we do see more often than not is if there is a logon script that executes when you log into your machine that tries to mount a file share on the network, and that file share was decommissioned at one point, it's trying to mount that and it's trying to then reach that. Therefore, it's not there, and it reaches out via LLMNR. Once the attacker gets that hash, the attacker just says, error, and the victim knows no different. They just get a cannot access. So like I said, this isn't very common, so there's another way to do this, and it's with WPad. So WPad stands for Web Proxy Auto Discovery Protocol. And there's a little misconception, if you Google this on the internet, of what it really is. WPad is the way a computer is going to search for something called the Proxy Auto Connection File, PAC file. And the PAC file is just the settings, the configuration file for your proxy settings. So if you're using a proxy in your network, you would set up a PAC file, and that way browsers can go through the proxy to get to the internet. So WPad specifies how to find this PAC file for your browser, for your computer. First thing it does is it goes to the DHCP server, and it says, do you know where the PAC file is? The DHCP server says no, then it goes to the DNS server. DNS server goes, no, don't know where it is. Finally, it falls back to old LLMNR, asks the entire network, does anybody know where the pack file is? And the attacker can do two things. They can do one, the same thing with the previous method, which is just give a challenge and have them encode that challenge with their password hash. Or they can actually just prompt for credentials. You can actually have a pop-up box show in the browser asking for them to input their credentials in order to access the internet. A little less stealthy. However, you do get clear text credentials in that case. So what does this actually look like? I apologize for the font size. I thought it was bigger, but in this environment, this isn't a virtual network. This isn't a client side or anything. I'm using virtual machines for this. So I have my Kali Linux machine here, and I am attacking a Windows 7 machine in this case. So first thing I do is I start up a tool called Responder. So Responder is just looking for these protocols, LLMNR, come across the network. So you can see it stands up a couple different servers, HTTP, WPad. So I go to my lab Windows 7 machine, and I fire up Internet Explorer. And as I explained, it now is looking for that WPad file, or for the pack file, via LLMNR. So then I get the poison answer, and I get the password hash for the actual machine account. The reason why I get a machine account, I do later on get a user account, but you get a machine account sometimes with this because Windows Updates is constantly trying to reach out to the internet, and it's doing that with the machine account. So again, even though it's not opening Internet Explorer or anything like that, your machine is still trying to get to the internet constantly. So what do I do with this? As I said before, you can just crack the hash. So with user accounts, you can if they have a poor password policy, you can crack that pretty quickly. We'll get into hash relaying in just a moment. So what are the mitigations for this? Well, you can turn it off via group policy, because the whole thing about this attack is that both of these methods, LLMNR and WPad, are enabled by default in group policy. To turn off LLMNR, there's the path there. MB TNS is the fallback from LLMNR, so you can disable that as well. People ask me, okay, what happens if I turn LLMNR off and my network isn't going to break anything? If your devices are relying on LLMNR to communicate, they're already broken. So this is kind of a test to see what is actually broken on your network. The thing about disabling MB TNS is if you are using fully qualified domain names for accessing something, that will break it. Turning off WPad, so you can just turn it off again via group policy. You can create a DNS entry for WPad as well. So when it searches for that file, it just goes to the DNS file, and you can just redirect it to localhost or whatever. Alternatively, Microsoft did patch this eventually, and it's called MS16-077, and it states the location of the WPad file is no longer requested via broadcast protocols, but only via DNS. So no more LLMNR or MB TNS for trying to find the pack file. And in Windows 10, if you just type in proxy, you can see it opens this box, and that is how you turn it off in Windows 10. So that goes to the next attack, which is IPv6 spoofing. So IPv6 is the quote-unquote replacement for IPv4. However, it's not widely used for internal networks. So these are examples of IPv6 or IPv4 and IPv6 addresses. IPv4 having a limited number, we already used all the amount of IPv4 addresses in the internet. So IPv6 is the replacement where we will never run out of IP addresses on the internet. There's a problem with this, though, in Windows, and it's a protocol, DHCP version 6. And there's a bigger problem, is that Windows prefers IPv6 by default, and DHCP v6 is constantly broadcasted to the entire network. So this happens all the time. I forget what the interval is, 5 minutes or something like that. For your computer broadcast, does anybody have an IPv6 address for me via DHCP version 6 to the entire network? And what an attacker can do is they can listen for this request to come across and respond with a response saying, yes, I am. Here's your IPv6 address. And by the way, I am also a DNS server for IPv6. And the attacker can register themselves as an actual DNS server. So that's what this looks like. So I'm on a Windows 10 machine right now. IPv6 is disabled at the moment. And I'll show you what happens when I enable it. So in PowerShell, if I just do ipconfig, there is no IPv6 address, and there is one DNS server, and it's an IPv4 address. So in Wireshark, I'm listening for DHCP version 6 requests. Back on my Kali machine, I use a tool called MIDM6, man of the middle 6. I just tell it to listen on my current adapter, internet adapter, and it's listening now for DHCP version 6 requests. So what I do is I turn IPv6 on in Windows, and you immediately see this protocol be broadcast to the entire network. And my attacker machine responds to those requests, and the attacker assigns an IPv6 address for that Windows machine, as well as registers itself as a DNS server. So if I do ipconfig again, you'll see that there is now a DNS server with an IPv6 address, which is me, the attacker. So if we go back, and we see that this patch, MS16077, says WPad files no longer search for via DNS, or via broadcast protocols, but only via DNS, and we now control DNS, well, we just bypass this whole patch. So we control DNS. What do we do now? So how many people here have heard of pass the hash? OK. If you haven't heard of pass the hash, with NTLM hashes in Windows, you can take that actual hash and pass it over via SMB and actually log into machines. You never have to crack the hash. When you do capturing of credentials via LLM&R spoofing, WPad spoofing, you get them in a different format called NTLM net v2. And these hashes cannot be passed. So we can do something else with these hashes, though, which is called relaying. So if we look at regular NTLM authentication, it's a challenge response protocol. So the server sends in a challenge back to the user. The user authenticates with that signed challenge. And if the domain controller or SAM can decrypt that challenge successfully, it logs you in, and you are who you say you are. Well, with hash relaying, what the attacker does is they sit in the middle of this whole exchange, and they watch it go back and forth until the very last part, where the attacker, instead of relaying the authentication success back to the actual user, they take that for themselves. And then that way, the server thinks the attacker is the one who is actually authenticated. So then the attacker can then send commands as the authenticated user. So I'll show you what that looks like. So back on my Windows 10 machine, again, the attacker computer is registered as a DNS server. And remember, IPv6 is preferred in Windows, so it's going to search for that first over IPv4. So what I do now is I set up my relay on my attacker machine, so NTLM relay. I'm telling it to work over IPv6, and we immediately see stuff come across. So again, what's happening now is, if you remember, Windows machines are constantly trying to reach to the internet, Windows updates. And when it does this, I do WPad spoofing, and I take those credentials that I find, and I relay them to the actual domain controller. And when I relay them to the domain controller, assuming that user has access, it then immediately dumps the local hashes, password hashes, on that domain controller. So you can see I authenticated as the computer account, and there's the administrator password for that domain controller. So back to my story, this is how I actually got in. I didn't have to do IPv6 spoofing. I actually just did regular WPad spoofing, and they had a couple Windows machines that weren't patched, and I was able to actually get credentials. So I was authenticated to the domain. Mitigations first. These are the mitigations for it. So you can add a registry key to disable IPv6. Alternatively, you can just turn it off in the adapter settings. DNSSEC as well, to make sure that you're not just getting anybody registered as a DNS server. And then SMB signing is what's used to prevent hash relaying. So anyways, I have credentials to the network now. I was able to crack them after I did WPad spoofing. And I started enumerating some file shares and stuff like that. I didn't find anything too interesting. So I needed to escalate my privileges on the network somehow. So I then resulted to looking at Kerberos. How many people here know what Kerberos is? A lot of people. How many people here actually understand Kerberos? You're lying. Kerberos is one of these things that is extremely difficult to understand. If you're not familiar with Kerberos and you just Google what is Kerberos, you start to get these images that are like, what the hell? There's no way you can decipher these just looking at them. So if you follow Swift on security, one time I tried to explain Kerberos to someone, then we both didn't understand it. So if you haven't gotten it, Kerberos is difficult to understand. So this is my shot at explaining it to you within 20 minutes. And you all will be Kerberos experts at the end of this, and there will be a quiz. So Kerberos Overview, it is the protocol that is preferred in a Windows domain for authentication. It's the alternative, or the NTLM is the alternative to this in a domain. It is very complex. The easiest way to think of this is think of it as like single sign-on, but for Windows. Kerberos isn't new. It's actually pretty old. I think it was made in the 70s by MIT. And now we're on Kerberos version 5, I believe. But before I get into how Kerberos works and all that, there's a few key terms that I want to cover first. And if you don't memorize these, that's fine. I cover them again. First thing is KDC, Key Distribution Center. KDC is, I've never not seen it on a domain controller. So if I say domain controller, DC, and KDC interchangeably, that's why. The Key Distribution Center is just the thing that does the authentication in Kerberos. And I'll explain what that actually looks like in a second. Service Principal Name, SPN, it is a unique name for a service account. So if you have multiple, let's say, MySQL services across their network, you need to be able to identify those services uniquely. Therefore, SPNs are set for that. As an example for a domain controller, if you want to access the file share on a domain controller, you'll use CIFS. And this is done through a program called setspn.exe. This is an actual executable on the domain controller, and I'm going to walk you through what that actually looks like. Ticket Granting Ticket, TGT, this is used to authenticate to the KDC. I'm going to show you how you get a TGT. This is just something that proves you are who you say you are. Think of it as almost like your driver's license. And then finally, Ticket Granting Server. We're just going to call this a service ticket. And service tickets are used to access services such as file shares, SQL, and I'm going to show you what that is too. So first things first is we need to get a ticket granting ticket. So how does that work? Let's say you have your Windows machine. It's connected to the domain, and you input your credentials to log in. What is actually happening? You are contacting the KDC, which, again, always, in my case, always the domain controller. It sends a request to the domain controller saying, I am trying to get a ticket granting ticket. Here is a timestamp encrypted with my password hash. And if the domain controller, which has your password hash, is able to decrypt that timestamp, it then knows that your password is correct. And then it issues you your ticket granting ticket. Again, think of this as almost like your driver's license. It is a proof of authentication. You are who you say you are. Now you may think, okay, well, why can't I just like take my TGT and just change the name in or anything like that? Well, it's actually encrypted with a very complex password for an account called the KRB TGT. This is a default account installed on the domain controllers or KDCs, and it has a super long password that you are not cracking in the next century. So that's what it's encrypted with, so you can't just crack it open and do whatever you want. So you have your TGT now. You are who you say you are. Great. You're logged into Windows. Well, next you need to let's say you want to access an email, you want to access a file share. In order to access a service on a remote host, the user needs a service ticket. You can't just access any service you want to. That'd be pretty insecure, right? So in order to access something, you need your service ticket, your TGS. The services are identified based on SPNs, as I explained before. The authentication actually occurs, or authorization occurs on the target host and service, not the domain controller or the KDC. So what are examples of service principal names, SPNs? So if I want to access a file share on a computer, the service is going to be CIFS. If I want to query the domain for info, I'm going to do that via LDAP. If I want to authenticate over to a web server, it's going to do HTTP. MySQL, it's going to be MySQL service. What does that actually look like, though? So just as a really small proof of concept, if you go to Windows Explorer and you type in any file share, and you're able to access it like that, you actually just requested a service ticket in the background. And it looks like this. So you, the user, actually first contact the KDC saying, I need to access in this case, a file server. I need to access CIFS on this file server. Can I get a service ticket? Here's my ticket granting ticket to prove it's me. You always have to show your ticket granting ticket before you ask for a service ticket. You have to prove you're authenticated to the domain. The KDC then goes, you got it, one service ticket coming right up. It never checks if you actually have access to that service or not. It doesn't care. That's not its job. It will always issue you a service ticket for any service you request it for. So it does something interesting then. It then issues you that service ticket, but it encrypts the service ticket with the target service's password hash. Why does it do that? Well, it does that because the only thing in common with the target service and the domain controller is that password hash. So it needs to prove that it can decrypt it some way, so that's why it's there. So this leads to an interesting attack called Kerberos Sting, where you request a service ticket which has the password hash of that target service, and then you crack it offline. You don't have to forward it, or if you do, you aren't necessarily going to have access to it, but you still have that account's password hash, so you can crack that offline. And remember, these can be requested by any user, so any privileges on the domain can request a service ticket by default. So that's what this looks like. So I'm on a domain controller right now. Now I'm going to do set spn.exe. I'm going to set a service principal name for an account. And it's just going to be CIFS, so file share, on the MS SQL server. And MS SQL service is just the name of the principal, and then the actual machine name, which is MS SQL service. So there's an SPN set for that. And I'm going to use a tool called Rubius to do Kerberos. And it's just Rubius Kerberos. And just like that, I have the password hash of that targeted service. So what I do now, I take this offline, crack it offline. And as I'm sure we all know, service accounts are never over permission, right? So what are the mitigations for this? This is Kerberos working as it is supposed to. It's working as intended. There are no quote-unquote fixes for Kerberos Sting. The mitigations for this are to A, have a very long password set for your service principal names. You honestly should probably not even know them. I always suggest password manager, something super long password. And then make sure no users have SPNs. If you're having users actually have SPNs to access services and stuff like that, that's bad news, that you're making shortcuts somewhere. So back to my story. I was able to successfully Kerberos a service account on the network. Again, low privilege credentials, now escalated to a service account. I had more access, a lot more access actually. Still didn't have access to the domain controllers or anything like that, which is where my golden objective was. So I needed to still escalate privileges somehow to be able to access a domain controller. So the next part I'm talking about is delegation tax. So there's three types of delegation in Windows or Active Directory: unconstrained, constrained, and resource-based constrained. There's a tax for each of these. However, I'm only going to focus on unconstrained for time purposes. So unconstrained delegation, user authenticates to a service or a server via a service ticket. The service then extracts that TGT from the service ticket to use it for other TGS requests. Very, very old method of delegation. And if you're unfamiliar with delegation, let's say you authenticate to a web server, right? The web server is going to impersonate its privileges as you. You don't want it running as just any administrative privileges constantly. So it's actually delegating privileges to act on your behalf with your privileges, so you can control permissions that way. So with unconstrained delegation, it's actually keeping a copy of the user's ticket granting ticket in memory, which is really bad, right? Because if we are able to then compromise a system that supports unconstrained delegation, we can then just pull TGTs straight out of memory. And remember, TGTs are the authentication in Kerberos. So I don't ever have to crack passwords. I don't have to do any of that. If I pull a TGT for somebody, I am them. And in group policy, with that, or not group policy, but if you look at the properties on a computer object and you click on the delegation tab down here, and it says, trust this computer for delegation to any service, this is Windows' way of saying unconstrained delegation. So if you have this enabled in any of your domains, bad news. And when I say this is old, I mean like this is like the first implementation of delegation in Active Directory. So it's like Windows Server 2000 old. So what does this actually look like? So if a user says, hey, I need to access the MS SQL database on you, web server, here's a service ticket, and the web server goes, OK, you're allowed to authenticate. I'm just going to take your TGT and hold on to it for future use. That way, if you need to authenticate later or for any other services, I have that TGT, and we can just do it that way. And if, for example, it does try to authenticate to something else, the unconstrained delegation server is just going to say, hey, user 01 is delegating me to request a service ticket for the MS SQL service. Here's their TGT. And that is the KDC then issues that service ticket back, and it looks like actually the original user requested it. So the thing about this is you need to be on an unconstrained delegation server and have actually somebody authenticated to it or on it already. So if we find unconstrained delegation and people remote desktop into it, easy win. However, that's not always the case. Unconstrained delegation, whenever we see this in a network, it's usually on old legacy systems, and people aren't consistently on that machine. So we need to be able to somehow course authentication to an unconstrained delegation server. And there's a very interesting attack that came out a couple of years ago by a coworker of mine called the printer bug. So a printer bug is taking advantage of the printer spooling service on modern Windows hosts. When triggered, it will actually authenticate back to whoever triggered it. If you're interested in the full write-up, my coworker's handle there on Twitter, Lee Christensen, or Tifkin, wrote a tool for this, and if you trigger this protocol, it's going to authenticate back to you. So if we can execute printer bug while we're on an unconstrained delegation host and trigger, say, the print spooler on a domain controller and have it authenticate back to us, we then have its ticket granted ticket in memory, and we can extract that straight out. The tool name that he chose for this was called Spool Sample. I had a coworker who had issues with his dog, and he took it to the vet, and the vet asked for stool samples, and he kept calling it Spool Sample because we use this so much. Anyways, so again, the whole purpose of this is to course a domain controller to authenticate to a host that has unconstrained delegation. And this is how printer bug works. And again, if we are the attacker host on the top left, we trigger Spool Sample on the domain controller, and the domain controller will authenticate to whatever host we choose. We can specify that in the actual tool. What are the mitigations for printer bug? Well, one, you can ensure sensitive accounts cannot be delegated. So this is definitely recommended for computer accounts on domain controllers, et cetera, domain admins, enterprise admins. You can also just disable the print spooler service domain controllers probably should not be printing much. But this also leads to another attack. And again, I'm going to group these all up into one, so I'm not skipping over demos or anything. But there's historically, when we were penetration testing, 5, 6 years ago, we would get onto a domain controller. We would make a copy, a shadow copy of the C drive or whatever the primary drive is, and extract the ntds.dit file out and extract all the password hashes out of that. That was problematic because A, it was extremely noisy. You had to be on a domain controller. And B, when you're making shadow copies of stuff and say the drive runs out of space or whatever, you're messing with domain controllers and you're going to be caught eventually. It's big red flags, and yeah, red teaming perspective is terrible. So luckily there's an attack that came out a couple years ago called DC Sync. DC Sync actually takes advantage of a feature with domain controllers that is replication. If you have multiple domain controllers in your network, they're consistently replicating with each other for redundancy purposes. Domain controller A fails, users can just authenticate to the domain controller B. So of course, in this replication, password hashes and password accounts and all that, or accounts are all synchronized back and forth. So there's a tool called Mimikatz that historically always tampered with passwords and password storage in Windows, actually implemented this functionality. So what an attacker would do now, in modern day, is they would do DC sync from whatever host they're on to a domain controller and have them just sync back the password hashes and accounts. And if you need a diagram for this, it's just consistently, again, domain controllers always replicating back and forth. If you compromise any server and they have replication rights, you can then DC sync the domain controller. So who has replication rights? Domain controllers. So the actual computer accounts on domain controllers. Domain admins also have this. Enterprise admins. Which goes into the mitigation stuff, which I'll talk about in a second. But let's see all of these attacks strung together now. So again, the whole thing here is via Kerberos, I had access to a service account. This service account had access to a computer with unconstrained delegation. With unconstrained delegation, I'm going to use printer bug to coerce a domain controller's computer account to authenticate to me, where I can then pull its ticket granted ticket out of memory, impersonate that account, and then do DC sync. So on the left, I'm doing Mimikatz. I'm just going to do DC sync just as a proof of concept to show you that I cannot do it right now with my current privileges. And we get an error back. I just don't have the privileges. And if we do who am I, I'm a low privilege user, lab Alice. And I am on the unconstrained delegation server. So with Rubius, I'm just monitoring now for incoming ticket granted tickets. I'm just listening to see if there's anything authenticated to this current computer I'm on. So I use full sample, and I tell it to authenticate or trigger authentication from the domain controller, lab 2012 DC01, and connect back to my current host that I'm on, lab Win10. You can see I immediately, once I trigger this, I get the ticket granted ticket back for the machine account on the domain controller. I then copy its TGT. I use Rubius to implement that TGT into my current session on this computer. So I then am essentially that machine account. I am the domain controller at this point. I then do, I check my tickets. It's proof right here that that ticket is now in my current logon session. So I am lab 2012 DC01. I do Mimikatz again, DC sync. And there's everybody's credentials. This is extremely common to find. If we ever find a machine in a network with unconstrained delegation, that is our #1 target every single time. Because we know we can easily do printer bug, and we can eventually do DC sync onto a domain controller. Mitigations for printer bug as well. It was quote unquote patched by Microsoft it still works. We don't know what the patch did. It still works. So this is still a current attack. So what we end up doing is something called the Credential Shuffle. So we compromise a machine. We escalate our privileges on that machine. We dump the passwords on that machine, whether it's a local, Kerberos, whatever. And then with the new credentials that we find, we see what we can log into, eventually hunting for an unconstrained delegation server. There's other delegations attacks, again, that I'm not going to go into, but we can escalate as well that way. Eventually, being able to DC sync, get the access that we need to whatever our objective is. The objective is not always domain admins or always compromise a domain controller. It usually is an objective, but oftentimes our objectives will be like try to find PHI or something like that. So with privileges to the entire network, we can easily do that. So now we're going to introduce a tool that we've developed, my two brilliant coworkers developed. They actually presented at HIPConf in New York last year on this tool. It's called Bloodhound. And this isn't just a defensive tool, it's also definitely an attacking tool. Bloodhound graphs the entire domain to reveal relationships between objects with an Active Directory. So again, what is an object in Active Directory? Policies, users, computers, etc. It is extremely useful for an attacker because it's actually going to map out attack paths for you, which in turn is also useful for a defender, right? If you know the attack paths an attacker can take, you can set up your defenses accordingly. So what does this look like? So in order to gather data via Bloodhound, you run the data collector, which can be an executable, it can be a PowerShell script, on the domain. And it uses LDAP to gather all the data for relationships and objects. So it's going to gather, it's going to touch objects to see, to gather info like when is the password last set, who's logged onto this computer, etc. Permissions are irrelevant for the most part. If you're trying to see who's logged into what, you do need administrator permissions. Otherwise, you can run this as a low privilege user and get a ton of information back. So this is the Bloodhound interface. And let's say I compromise an account called backup LDAP. I'm going to set this as my starting point. And I want to see how do I get to the domain admins group. And it maps out my path for me. So the account that I compromised, backup LDAP, if I click on it, you can see when the password was last changed. We can see if it can be delegated, all that stuff. We can see it can log into a machine called Diamond. And we see that it supports unconstrained delegation where a domain administrator is logged into. And as we just learned, that ticket granted ticket's then in memory in clear text on that machine that we have access to because of unconstrained delegation. So if I log into that machine, dump the TGTs, I then can just straight up impersonate the domain administrator. And I'm part of course, the domain admins group. So very, very useful from an attacker perspective as well as a defensive perspective. Yeah? OK. So what this ends up being most of the time is like a wild goose hunt for either A, unconstrained delegation servers, seeing where the domain admins are logged into, all of that stuff. It can get pretty crazy. And this is actually, like if this looks complicated, it can get absolutely crazy. That's it. So credits. Well, one of my coworkers, so Will Schrader, Andy and Rohan, Sean Metcalf for answering a lot of questions on Kerberos, Lee for printer bug, Tim Medine, who discovered Kerberos a couple years ago, Spider Labs from Packet. They did all the responder and stuff like that. Can I just get the too long didn't read version, please? Default group policy is bad. Disable LLMNR, disable WPad, disable IPv6. Stop setting SPNs for users. Don't use unconstrained delegation. Bloodhound is great. Patch. Anybody have questions? Any questions at all? Yeah.
Weren't they using your printer bug against Exchange servers about a year ago?
Yeah, so historically, Exchange servers are always over-permissioned. So if you don't want to trigger authentication from a domain controller because you think they might have like a defense set up on a domain controller, you can do it via an Exchange server, and that's usually a good way in as well. There was another attack called PrivExchange that came out last year around very similar triggering authentication via an API with the Exchange servers and having it authenticate back and getting its credentials. But yeah, any other questions? Yeah.
So you focused a lot on the Windows side. Have you looked at the non-Windows, like the Nix? Are there similar vulnerabilities in that?
Yeah, so my coworkers are definitely way better at that than I am. There's a couple blog posts that we actually just released one 2 days ago on doing it in Mac OS environments. And then there is an actual implementation of Active Directory in Linux called FreeIPA. And it actually solves a couple of these vulnerabilities. It's implementation of Kerberos. So yeah, it's out there. If you just look on our blog, there's numerous articles on that. Any other questions? Okay, cool. Well, thank you.